Barrage vs. Dam, differences. Outline. Introduction. A. Brief overview of barrage and dam. B. Importance of water management structures. 2. Barrage, definition and function. A. Definition of a barrage. B. Purpose and functions of a barrage. C. Examples of barrages and their applications. 3. Dam, definition and purpose. A. Definition of a dam. B. Primary purposes of dams. C. Various types of dams based on construction and usage. 4. Structural differences. A. Design and construction of barrages. B. Design and construction of dams. C. Varied sizes and dimensions of barrages and dams. 5. Functional differences. A. Water flow management in barrages. B. Water storage and release in dams. C. Generation of hydroelectric power in certain dams. 6. Environmental and socioeconomic impact. A. Effects of barrages on aquatic ecosystems. B. Impact of dams on river ecosystems and fish migration. C. Resettlement and displacement due to dam construction. 7. Case studies. A. Barrage case study with its benefits and challenges. B. Dam case study highlighting its advantages and controversies. 8. Comparison and contrast. A. Key similarities between barrages and dams. B. Highlighting the main differences in purpose, design, and function. 9. Future considerations. A. Trends in sustainable barrage and dam construction. B. Potential alternatives and innovations in water management. 10. Conclusion. A. Recap of key points discussed. B. Importance of balanced water resource development. C. Final thoughts on the significance of understanding barrage and dam differences. A brief overview of barrage and dam. Barrages and dams are pivotal water management structures that shape the way we interact with and utilize water resources. Barrages are engineered barriers designed to regulate water flow, control salinity, and manage tidal dynamics in estuaries and coastal areas. On the other hand, dams are massive constructions that serve multiple purposes, from storing water for irrigation and energy production to controlling floods and providing recreational opportunities. Both barrages and dams play critical roles in reshaping natural water systems to meet human needs. B. Importance of water management structures. Water is a finite and essential resource that sustains ecosystems, economies, and societies. Water management structures like barrages and dams offer a means to harness, control, and allocate water for various purposes. They enable us to ensure a consistent water supply for agriculture, industry, and urban areas while mitigating the risks associated with flooding and droughts. As the global population grows and climate patterns shift, the role of these structures becomes even more vital in securing reliable water resources for future generations. Barrage, definition and function. A. Definition of a barrage. A barrage is a man-made hydraulic structure constructed across a river, estuary, or tidal inlet. It consists of a series of gates, barriers, or sluices that can be raised or lowered to control the flow of water. Barrages are designed to regulate water levels, prevent tidal ingress in estuaries, manage salinity levels, and aid navigation. B. Purpose and functions of a barrage. Water flow regulation. Barrages control the flow of water by adjusting the gates, helping to manage water levels upstream and downstream. Salinity control. Barrages and estuaries prevent the intrusion of seawater, maintaining a balance between freshwater and saltwater. Navigation improvement. By managing water levels, barrages facilitate the movement of ships and vessels along rivers and tidal waterways. Flood prevention. Barrages can play a role in mitigating flooding by managing water discharge during heavy rainfall or high tides. Irrigation support. In some cases, barrages are used to divert water for agricultural irrigation. See examples of barrages and their applications. Thames Barrier, United Kingdom. The Thames Barrier protects London from tidal surges, preventing flooding and safeguarding infrastructure. Haringvliet Barrier, Netherlands. This barrage controls the flow of water between the North Sea and Haringvliet Lake, managing salinity levels and preserving freshwater ecosystems. Seabrook Barrage, India. Constructed across the Hooghly River, this barrage supports irrigation, navigation, and water supply for Kolkata and its surrounding areas. Dam, definition and purpose. A definition of a dam. A dam is a human-made structure designed to impound and control the flow of water in a river, stream, or watercourse. Dams typically consist of a barrier built across a waterway, creating a reservoir behind it. B. Primary purposes of dams. 1. Water storage. Dams store water in reservoirs, which can then be used for various purposes, including drinking water supply, irrigation, and industrial needs. 2. Hydropower generation. Many dams are equipped with turbines and generators to harness the kinetic energy of flowing water, producing electricity. 3. Flood control. Dams regulate water flow during periods of heavy rainfall or snowmelt, reducing the risk of downstream flooding. 4. Recreation and reservoirs. Dams create reservoirs that offer recreational activities such as boating, fishing, and water sports. See various types of dams based on construction and usage. 1. Arch dams, curved structures that rely on their shape and the strength of the material to withstand water pressure. 2. Gravity dams, massive dams that use their weight to resist the force of water, often built from concrete or stone. 3. Embankment dams, constructed using compacted soil, rock, or other materials to create a barrier. 4. Buttress dams, feature triangular supports along the downstream face to distribute water pressure to the foundation. 5. Concrete face rockfill dams, combination of earthfill and concrete to create a stable and durable structure. 6. Roller compacted concrete dams, fast construction method using compacted concrete for dams with lower water pressures. 7. Earthfill dams, built using layers of earth and rock materials, often with an impermeable core to prevent water seepage. 4. Structural differences. A. Structural differences in the design and construction of barrages could include variations in materials used, the shape and configuration of gates, and the overall layout to manage river flow. B. Structural differences in the design and construction of dams may involve variations in dam types, example, arch, gravity, embankment, the height and thickness of the structure, and the mechanisms for controlling water release. C. Varied sizes and dimensions of barrages and dams refer to differences in the physical characteristics such as length, height, width, and storage capacity, which are tailored based on the specific needs and conditions of the water bodies they manage. 5. Functional differences. A. Functional differences in water flow management in barrages involve regulating river flow, sediment control, and diversion of water for irrigation or navigation purposes. B. Functional differences in water storage and release in dams include controlling the reservoir's water levels, managing floodwaters, and releasing water for downstream uses like agriculture, municipal supply, and ecosystem support. C. The functional difference of hydroelectric power generation in certain dams entails harnessing the potential energy of flowing water to produce electricity through turbines and generators, which is not a primary function in all dams. 6. Environmental and socioeconomic impact. A. The environmental impact of barrages on aquatic ecosystems can include disruption of natural flow patterns, changes in sediment transport, alteration of habitat for aquatic species, and potential reduction in biodiversity. B. Dams can have significant environmental impact on river ecosystems, affecting fish migration, altering water temperature and chemistry, and fragmenting habitats, which can lead to decline in fish populations and changes in overall ecosystem dynamics. C. Resettlement and displacement due to dam construction refers to the socioeconomic consequences where communities living in areas that will be submerged by the dam's reservoir are forced to relocate. This can lead to loss of homes, livelihoods, and disruption of traditional ways of life. 7. Case studies. A. Barrage case study. The Sardar Sarovar Barrage on the Nirmada River in India benefits irrigation, provides water for irrigation to agricultural lands, enhancing crop productivity. Flood control, helps regulate river flow, reducing the risk of flooding in downstream areas. Water supply, supplies drinking water to villages and towns in the region. Challenges. Environmental impact, alters natural flow, affecting aquatic ecosystems and sediment transport. Displacement, led to the displacement of numerous communities due to reservoir creation. Socioeconomic effects, impacts livelihoods and traditional practices of displaced communities. B. Dam case study. The Three Gorges Dam on the Yangtze River in China advantages hydroelectric power, generates a large amount of electricity, reducing reliance on fossil fuels. Flood management, helps control flooding in the Yangtze River basin. Navigation, improves river transportation by regulating water levels. Controversies. Environmental impact, alters river flow, impacts aquatic ecosystems, and causes sedimentation. Displacement, resulted in the relocation of over 1 million people due to reservoir creation. Geological concerns, raised worries about landslides and other geological effects due to the dam's weight. 8. Comparison and contrast. A. Key similarities between barrages and dams. Water management. Both barrages and dams play a crucial role in managing water resources by regulating flow and controlling water levels. Engineering structures. Both are engineered constructions designed to manipulate water flow for various purposes. Impact on ecosystems. Both can have significant ecological impacts, affecting aquatic habitats, wildlife, and fish populations. Societal benefits. Both contribute to human activities, such as irrigation, water supply, flood control, and energy generation. B. Highlighting the main differences in purpose, design, and function. Purpose. Barrages focus on controlling water flow, preventing tidal ingress, and maintaining freshwater in estuaries. Dams are primarily built for water storage, hydropower generation, flood control, and other purposes like recreation. 2. Design. Barrages often consist of gates or barriers that can be raised or lowered to control water flow. Dams feature a barrier structure that retains water to create a reservoir. 3. Function. Barrages primarily manage water flow, prevent saline intrusion, and support navigation. Dams store water, release it as needed, and generate hydropower. 4. Size and dimensions. Barrages are generally smaller in scale, often spanning narrower water bodies. Dams can vary significantly in size, from small to massive structures with vast reservoirs. 5. Location. Barrages are commonly built across estuaries, tidal rivers, and coastal areas. Dams are constructed along rivers, valleys, and other suitable locations. 6. Impact. Barrages can affect tidal patterns, salinity, and fish migration in estuarine ecosystems. Dams alter river flow regimes, sediment transport, and fish habitats, impacting downstream ecosystems. 9. Future considerations. A. Trends in sustainable barrage and dam construction. 1. Eco-friendly designs. Emphasis on using sustainable materials and construction techniques to minimize environmental impact. 2. Nature-based solutions. Integrating natural elements like vegetation and wetlands to enhance water management and ecosystem resilience. 3. Climate adaptation. Designing barrages and dams to withstand changing climate conditions, including increased flooding and rising sea levels. 4. Fish-friendly structures. Incorporating fish passages, fish-friendly turbines, and other measures to mitigate negative impacts on aquatic life. 5. Smart technologies, using sensors and real-time data to optimize water flow control and operational efficiency. 6. Adaptive management, implementing flexible designs that can be adjusted over time based on changing needs and environmental conditions. B. Potential alternatives and innovations in water management. 1. Rainwater harvesting, implementing systems to collect and store rainwater for domestic and agricultural use, 2. Managed aquifer recharge, storing excess surface water in underground aquifers during wet periods for later use. 3. Desalination, expanding the use of desalination technologies to provide freshwater from seawater sources. 4. Microhydro systems, utilizing small-scale hydroelectric systems in rural areas to provide decentralized power generation. 5. Water recycling, treating and reusing wastewater for irrigation, industrial processes, and even drinking water. 6. Floating solar panels, installing solar panels on water bodies, helping with energy generation and reducing water evaporation. 10. Conclusion. A recap of key points discussed in this exploration of barrages and dams. We've examined their definitions, purposes, structural differences, functional variations, environmental and socioeconomic impacts, and future considerations. Barrages and dams, while distinct, share common goals of managing water resources and benefiting societies. B. Importance of balanced water resource development. Achieving a balance between water resource development and ecological preservation is crucial. Barrages and dams offer essential benefits such as flood control, energy generation, and water supply. However, their impacts on ecosystems and communities emphasize the need for careful planning, sustainable practices, and thorough assessment. See final thoughts on the significance of understanding barrage and dam differences. Understanding the differences between barrages and dams is paramount for informed decision-making. Whether addressing environmental concerns, meeting energy needs, or ensuring water security, recognizing these differences enables us to develop solutions that harmonize human needs with the health of our planet's ecosystems. By embracing innovative technologies, nature-based approaches, and adaptive management strategies, we can navigate the complexities of water resource management and work toward a future where barrages, dams, and other water management structures contribute to a more sustainable and resilient world. Thanks for watching. Please like, share, and subscribe. Teacher G.